A good day, guys. So today we are going to look at um, second topic. The second topic I want us to look at is dimension. So this is like a dimension of what derived quantities. So from this dimension, you now know some of the examples of derived quantities and their units. Okay, if you come to um, derived quantities, so the first thing I want you to know in dimension is that we've used the first letters of fundamental quantities to determine dimension of derived quantities. So what are the first letter of a fundamental quantity? We normally use that three most important fundamental quantities, which are MLT, mass, length, and time. Then these are the popular ones we use. Sometimes we can current. Just know that let's say um, for other ones like now current, we can use the symbol of current is I. So we can, when we are talking about the one that, no, when we do like EMF, that is V equal to IR. That's where you understand the one of it. But the popular ones that we will be seeing basically is this mass length and time. So let's start with this. So let's start with the first one. I want us to start with velocity. Velocity is distance over time. So velocity is distance over time. So then distance is length over time. So which is now what LT minus one. Reciprocal law. LT minus one. Then number two, I want us to look at is acceleration. Acceleration is velocity over time. Velocity over time. And you already know velocity is LT minus 1 over T. Like this is raised to power 1. This thing is 1 plus 1. When it goes up like this, it will be minus 1. So it will now be what? LT minus 1 minus 1 equal to what? LT minus 1 is what? Minus 2. So, so it means that the dimension of velocity is LT minus 1. If I want to now look at the units of velocity, L is meter, T is seconds, that is meter per second. Then this one is L is meter, T is seconds, which is so that is why acceleration is meter per second square. Any question? Okay. Then number three is we look at force. What is the formula of force? Force is mass times acceleration. And mass is m, acceleration is LT minus 2. So this is the dimension of force. Then number four is work. Work or work done. Okay, work and energy, they are used interchangeably. Work and energy, whether kinetic or potential energy, they are used interchangeably. And work normally, okay, let me put it so that it's not confuse us. Work is force times distance. Then force is, we have gotten force, MLT minus 2. Then distance is L times L, abi? This is L raised to power 1, L raised to power 1. In multiplication law of indices, when the bases are the same, you add the powers. So this is 1 plus 1 is 2. ML2 T minus 2. So this is the dimension of what? Work. Any question? Okay, so let's go to number 5. Number 5 is power. Power is work over time. Okay, don't worry. I want us to look at energy first. Energy. Okay, we have two forms of mechanical energy. Let's say potential energy. Potential energy. Potential energy is mass times gravity times height. And you already know mass is m, gravity is acceleration, which is we got acceleration at LT minus 2. Then height is L. So the same way, raised to power 1, raised to power 1, then you now see that is ml squared t minus 2. So are you saying that potential energy, that is energy, which is potential energy and work is the same thing, ml squared t minus 2. Then the same thing, even if you check kinetic energy is half mv squared. We don't include numbers in dimension, so the numbers are dimensionless. So mass is m times velocity is lt minus 1 and the square. So 2 times this thing is what? ml square. 2 times minus 2. No, this is raised to power 1. 2 times 1 is 2. 2 times minus 2 is what? 2 times minus 1 is what? Minus 2. ml to ml square. Are you seeing both energy and work? They have the same dimension. Then number 6. Okay, let me clean up. Number 6 is let's look at power. Power is equal to force over, sorry, work over time. And what is work? ml square t minus 2. ml square t minus 2 over t. This is raised to power 1. If this one goes up, it will be minus. So minus 2 minus 1, it will not be what? ml square t minus 2. This one goes up like this, it will be minus 1, which is what? ml square t minus 3. So this is dimension of what? Power. Any question? Okay, then let's look at number 7. Number 7 is, let's look at impulse. Impulse is force times time. Impulse is force times time. And force is force is mass times acceleration, which is m lt minus 2 times by t. Time is t. This is raised to power 1. This is m l. This is minus 2 plus 1 is what is like 1 minus 2, which is minus 1. lt minus 1. So this is the dimension of what? Impulse, force times time. Then the next one is number 8 is momentum. Momentum is mass times by velocity. And mass is m, velocity is lt minus 1. So are you saying that impulse and momentum, they are the same what? Dimension. Impulse and momentum, they are the same dimension. That is why I will not say therefore, according to Newton's second law of motion, you say that impulse equal to change in momentum. That impulse is equal to change in momentum. And you already know impulse is Ft. Change in momentum is mass, like momentum, like that is final velocity minus initial velocity. That is change in momentum. Therefore, if you make F the subject, you now see that F is equal to m bracket v minus u over t. So this is a popular formula all of us knows as second law of motion. You know, F force equal to mass times acceleration is first law. Don't worry. When we look at linear momentum, we'll talk about all those things. Then number 9, let's look at density. Density equals to mass over volume, which is what? Mass is m, volume is L cube, that is length times width times height, L cube. That is, you know, reciprocal of ml minus 3. So this is the what? Density. For density, ml minus 3. Then let's clean up again. Number 10, let's look at upthrust. Upthrust is density. You know, the symbol of density is rho. They used to call it rho like this. So is rho GH. You understand? Rho GH. Rho is density and density is ml minus 3. Gravity is lt minus 2 times height is length. So how many L do we have? This is like L raised to power minus 3, L raised to power 1, L raised to power 1. 1 plus 1 is 2. Then minus 3 plus 2 is like 3 minus 2, which is minus 1. ML minus 1. So, if I collect the powers like this, let me make it simpler. It's minus 3 plus 1 plus 1, then T minus